All right, we are going to call this video 3.1 Part 2.1 because this really should have been included in the Part 2 video. This is going to be derivative notation. Okay, and there are a lot of ways that you can write the derivative. And so I'm going to try to lay out the different ways here. Each one has pros and cons and is useful in different situations depending on the context of the problem. So the first way, so let's start off, we're given some function y equals f of x. And what I'm going to give you is the notation and then how it's read. So read as, okay. So first one we'll look at is y prime. Y with an apostrophe, it's read as y prime. It's useful because it is pretty short to write, pretty simple to write. Tells us that we're taking the derivative. It does not pack very much information into it. Related to that one is this one that we've mentioned a couple times in class, f prime of x, and it's read f prime of x. Okay, so that one is more useful just from the standpoint of it tells you what function you're analyzing, f in this case, and it tells you the independent variable, and still pretty shorthand. So that's one that I like a lot and we'll use quite frequently. Here's the next one, dy dx. That is read as dy dx. Okay, this looks like a fraction. It's not exactly a fraction. And I don't want to go too far into it because at this point in the course it's going to be confusing. So I'm not. But for right now, just think of that as notation. That means, well, it means this. So you can read that as dy dx, or you can read it as the derivative of y with respect to x. Okay, so the derivative of y with respect to x, I like this version of I like this notation because it packs a lot of information into it. It says you're differentiating y, so that tells you your dependent variable, and with respect to x tells you that you're differentiating with respect to the independent variable x, and that'll become more important as the problems get more complicated and more diverse. So when we're looking at position versus time functions, for example, will be useful in that context as well. This next one, this next notation, try again, 4, is very similar to the previous one, df dx, and that is read df dx, just like I said, or you can read that as the derivative of f with respect to x. Okay, so this one is similar to the last one, although a little bit less useful, I think, and doesn't come up as frequently as dy dx or f prime, or y prime for that matter. So this is probably the least common one that we'll use in class. All right, the last notation here is d dx. This is read as the derivative with respect to x of f of x. Okay, I'm not going to write all of that out, so you can just read this as d dx of f at x. All right, the one thing that I like about this notation is it indicates that differentiating is an action or an operation that you're performing on the function. So I'm going to differentiate f of x with respect to x. In other words, I'm going to differentiate this function with respect to that independent variable. Okay, so again, a lot of this, you'll see its use later on in different types of problems. One thing I did want to note about 3, quick note on 3, is this. Suppose that I give you this function y equals 4x cubed. So I take that function, and I could ask you something like this. I could say, well, what is the derivative of y with respect to x? So that's where that notation would come up. It tells you you're differentiating y with respect to what variable? Well, with x. Okay, and so, we don't know what that is. It's something, doesn't matter, okay? You can also, suppose that you don't have a function with y and x. Suppose that I gave you a position function, right? So I maybe give you s equals t, 4t squared minus t, right? I could ask you, using that notation, I could say, well, what is the derivative of s with respect to t? And then, that might be something, but it doesn't matter what it is. The point here is that my derivative notation scales to other types of functions. So the dependent variable here is s, the independent variable is t, and that means the derivative of s with respect to t. Okay, one last thing here. Suppose, again, I give you this function s, but I write it like this. S of t is equal to 4t squared minus t. I could ask you a couple things. I could say, well, what is s prime of t? So even that f prime notation scales to this type of problem. I could also say, hey, what is the derivative with respect to t of that function? And then, so you'd be performing the operation of the derivative on both sides. And so then you might write, well, Mr. Cresswell, the answer to that would be that ds dt is equal to, and then whatever you get for the derivative. Okay, so hopefully this video sort of helps you understand all the different notations for a derivative and how they might be used in different contexts. Like I said, the more you use these, the more familiar you get with them, the better. And as we go through, I will highlight, okay, we're going to use this notation in this context because it's useful for this reason. So don't worry, if this is all confusing or a little bit confusing at this point, it'll all become clearer the more that we use them. So yeah, that's all I got on derivative notation.